So good morning, one and all, and welcome back to the online learning platform at Department of Civil Engineering. Today, we all have gathered here for an interesting session on constructed wetlands for wastewater treatment, being presented by Dr. Shashibushana sir, who is presently the head of the department and manager of Environmental Engineering Department in Bharat Electronics Limited. It's my pleasure to welcome sir and also read his introduction out to you. Okay, Shashibhushan sir is basically a BE in civil engineering and masters in industrial pollution control. Also, he has completed his PG diploma in industrial safety, and I'm very happy to say that the industry person in front of you is also a doctorate holder. He has his PhD in environmental engineering. Sir did his master's from NITK, that is NIT Surathkal, and his bachelor's from JNCE, that is Kuempu University. Okay, now his experience is very vast. If you look at his academic project profile, he did his undergraduate project on a micro hydel power plant. Okay, his postgraduate work was basically on flocculation studies. Friends, what I'm trying to tell you is whatever you have been learning in your 5th sem and 7th sem as a part of your curriculum, as a part of your topic, sir has done project work on the same. That is where knowledge enhances when you apply the knowledge. So his project works were all application of the knowledge itself. Okay, now sir is presently working in Bharat Electronics Limited. So you know very well it is not easy to get an industry person and especially a person who is from a public sector and a defense background. Okay, now when it comes to sir's experience with respect to BEL, okay, he is very compliant with environmental legislations. You name it, he is aware of it, whether it's Water Act, Air Act, EPA, Forest Act, sorry, Factory Act, okay, Water Cess Act, Hazardous Waste Management Act. I'm also very happy to inform you that previously, a couple of years back, sir had come to our organization and he had delivered talks in person wherein he spoke about hazardous waste management, which is happening in Bharat Electronics Limited. The beneficiaries of that talk were the students of environmental protection management, that is the students who represented an open elective and were from other disciplines. Okay, today we are all lucky. Despite COVID, sir has made time for us, and in this online forum via Google Meet, okay, we will be engaging a session on constructed wetlands. Okay, so friends, with this brief introduction to our very honorable chief guest, okay, on behalf of the management, principal, behalf of my colleagues, my students, I welcome you, Sunil sir. I welcome you to this occasion, and I wish you a very happy New Year and a happy New Year to my students also. Happy New Year, sir. Sunil sir.
Very good morning.
Good morning, sir. Yes, sir.
Very good morning to one and all. And first of all, I wish very happy, prosperous New Year to all college guests as well as the dear students. Shall I continue with my presentation, sir? Is it visible there?
Yes, sir, it is visible. My dear students, please pin Sunil Kumar's sir's presentation. Okay, he has joined with the login ID of Sunil Kumar. So kindly please log in with that ID itself. Please pin your presentation to that. Sir, your presentation is visible. You may kindly continue, sir. Thank you, sir.
Thank you. So today, I'm going to just talk about the constructed wetland for the wastewater treatment and its application. So in this, just before we entering into the constructed wetland, let's just see what is the wastewater treatment scenario and why the wastewater treatment is essential at the moment. In this regard, you are aware that 0.01% of the total planet water is only available for the consumption and which is accessible. So, but the wastewater generation scenario, if you see as per the Pollution Control Board assessment, Central Pollution Control Board assessment 2015, their estimated sewage generation is 62,000 million per day. Installed capacity of 1816 STP, it's amount to be 23, and there is a sizable gap exists for the wastewater treatment. That is the reason you can see nowadays many treatment plants are going to come up, and they are increasing the treatment plant capacity numbers as well as the treatment quality also. So this indicates there exists a sizable gap for the wastewater treatment plants. So they have assessed. There are two things. One is if the water is not treated and discharged, and if the water is treated and it is partially treated and discharged, what are the effect? See, both the things leads to the poor water quality of the surface water, lake, or whatever it is. So they have also made a detailed survey at CPCB conducted a detailed survey at 120,275 locations covering the 455 rivers for assessing the suitability of the water quality. They found that around 718 locations are not meeting the water quality with respect to BOD and coliform. So this indicates that there is a huge demand and there is a necessity to have a different kinds of the treatment plant for the wastewater treatment and keeping the surface water to its purest form. So just few slides I will show what is happening presently. You can see many of the urban cities and all, they are receiving the sewage directly. Either it may be a lake or it may be a river, they directly receive the untreated sewage or partially treated sewage along with so many the debris, in the sense plastic, cracks, and so many things. So this is the implication of that. If you don't treat the sewage and if you don't prevent the pollution of these lakes and other things, these are the effect which we are going to see in the later part of time. Now, so I would like to say that a lot of initiatives have been taken for the rejuvenation of the lakes, rivers, and all, and Ganga rejuvenation plan also is going in a very bigger way. This is for your information. So further, when we come to the water pollution, you can see the plastics and other things, and third photographs you can see in the bottom, it is eutrophied lake. In the sense, because of the high nutrient other things, the growth of the vegetative is abundant, and which is creating the water surface will be covered and the biodiversity of the ecosystem of the lake getting disturbed. So this is due to the partial treated, and other things you can see if they don't treat and what is going to happen to the lake. Coming to the further on the eutrophication, what is happened? See, you can see what has happened in the one lake. It is totally covered with the weeds. So entire surface will be covered, then penetration of light will be affected, totally lake is getting disturbed. So which requires regular cleaning. If you discharge even untreated water also, which is having high nitrate and phosphorus content. Further, the Ganga rejuvenation plan, as I told, they have considered several treatment plants for the wastewater treatment. There is a detailed report available on the Ganga rejuvenation plans made by Indian Institute of Science across the India, and they have selected several technologies. So few among them I'm going to mention here is one is the activated sludge process is there, sequential batch reactor is there, moving bed bioreactor, upflow anaerobic sludge blanket, extended aeration, membrane bioreactor, waste stabilization pond. These are the things which they have recommended for the cleaning of the wastewater. But you can see here constructed wetland is not appearing in this one. So which indicates that there needs to be a lot of study on this constructed wetland and implication of this wetland for the wastewater treatment. We are going to see in further slides that what is constructed wetland, how it is constructed, and what are the advantages of this constructed wetland in the further slides. So just to bring to the treatment platform, this is the activated sludge process, how the configuration is. See, there will be aeration tank followed by a clarifier and the sludge removal process. This is how the mass balance is done. Influent is let into the aeration tank. It is clarified there. Solid liquid will be separated. Treated effluent will be taken for further application. Whatever the organic matter and other things available in the sewage are treated and removed as a sludge matter in the form of the biomass. This is how activated sludge configuration will be there. Next one is the sequential batch reactor. So this is being widely used because of it is having the advantages of nitrification, denitrification, phosphorus removal in the same reactor where the less area is sufficient for the treatment of the wastewater. Their sequencing batch reactors are also coming up heavily in the wastewater treatment applications. This is the extended aeration process where the retention time will be maintained very high. So thereby the high load BOD and high load BOD organic BOD effluent and the more efficiently treatment also can be done. But these are all the one through process where until unless we have the nitrification and denitrification process, the nitrate will be present in the treated effluent. So this is the membrane bioreactor which gives directly the tertiary treated water level. Cost of capital cost of this one is compared, it is high compared to other treatment plant. So, but this gives the very clear water wherever the water is being used for the toilet flushing and other direct application. This is being used. Cost is comparatively high. So this is the waste stabilization pond which you could see in the very olden days. You are able to see that, and some village places also these things are available. It doesn't require much science intervention, and the O&M in the sense operation maintenance also very less. You leave the water and automatically by the natural process it gets treated and which comes out. Again, huge area is required and quality of the water which is going to come out from the stabilization pond is comparatively less. This is not going to meet the latest standards. So combination of all these treatments have been published, and this combination of all advantages and disadvantages of each have been utilized, and it is made into the system, and required the level of water is being getted from this one. So now directly we come to the today's topic of constructed wetland with this brief. Why we are studying constructed wetland as an prospectus treatment plant for the wastewater treatment application, especially for the sewage treatment, which is highly having the organic content. You can see the two slides here. One is the wetland. Wetland are the any natural depression where water is getting accumulated. Once water available, invariably the vegetation and other microorganisms will grow. That also start treating the water. The right hand side, what you see is the engineered wetland. It is constructed wetland. So it is having the engineering control mechanism. In the sense, we design what is the hydraulic retention time and so many other factors, process control parameter, which we are going to study further. See, advantage of this constructed wetland is it is a low cost treatment and low technology. In the sense, the cost of construction is comparatively very, very low. Vis-a-vis, the area available is comparatively, area required for the construction is higher compared to other treatment plant, and low technology. In the sense, only plant will grow, it will take the organic matter and it will purify the water. No process control in a huge way. It is required as required for the sequential batch reactor or activator sludge process or membrane bioreactor. Membrane bioreactor, there is a chances of breakage of this membrane, sewage will come, enter in to the final treated water. Those issues will be there. In sequential batch reactor also, you have to maintain the dissolved oxygen content and recirculation, all those things. Here nothing is required. Only it is a one through process. Leave the water at the inlet point. It's getting distributed across the root zone, in the root zone of the plant and the media. So water while coming out, it is just getting treated. So this is basically the constructed wetland application. Now, you can just pictorially it is shown for to understand what are the components will be there to understand further details. You can see here, it is a constructed wetland. First point is the water entry point. There it is discharged to the wetland portion. In the wetland portion, so there will be a plants and there will be a media. So below that there will be an impermeable membrane will be there, so that whatever the sewage is let out, it is not just getting into the water ground and getting polluted. So finally there will be a exit of the water which will be taken out, and based on the retention time and plant and the combination of these, we are going to get the treated water quality. So this is the basically a constructed wetland process. So am I going in the right way? Are you able to catch me?
Yes, sir.
Okay, thank you. Now just we'll see how the constructed wetland application in present scenario. So many successful stories are there in many developing countries. the constructed wetland is being used widely. But in India, you can see now it is started coming up, but it is not in a very bigger way it is coming up. So wetland treatment has been proved for industrial as well as domestic wastewater also. For industrial application, just to mention, it is used for absorbing the copper and other things. Some heavy metals are also being absorbed by the plant. In that way, so constructed wetland is used for industrial effluent also in many places. And domestic, since it is organic matter, it is highly compatible with the plants and other things, and it is being used. It can be used very for the domestic wastewater. And with respect to the cost and requirement, only we have to bear the area of the land. See, it is a low cost, easy to operate, require less maintenance. Only area available is comparatively higher. So another advantage of this constructed wetland, it looks like a garden. Aesthetic plants, if it is planted as a vegetative plant for absorbing the organic material, it looked like a garden or anything. That is one advantages it is having, because the sewage treatment plant, some portion aeration tank and other things are exposed. People are having the aversion to have these plants near their habitat or the locality. But if the constructed wetland is constructed, it can look like a garden also. So moreover, it can be a habitat for the many aquatic and terrestrial species. These are the advantages of the constructed wetland. So only the disadvantages foreseen at this point is, one is the huge area and another one is the quality of the treated water. It will not be as good as the tertiary treated water, what we called is directly the membrane bioreactor. Otherwise, it can able to meet the treatment quality of other treatment which is presently being used. Now, see wetland. What are the classification of the wetland and how it is being configured? See, wetlands are classified based on the types of the macrophytes. Based on the macrophytes, it can be classified as free-floating macrophyte based, emergent macrophyte based, submergent macrophyte based. You can see in the pictures what are the free-floating. It is just a free-floating. It is floating from the top, and the root depth will be maximum 10 to 15 centimeter. So if the emergent microphyte system, see, it goes from the bottom, but it will be within the. So emergent is the one which goes from the bottom and it will come above the water surface. Some plants can go up to 2.5 meter, 3 meter also. See, normally it grows between 1.5 to 2 meter. There are some species are there, alligator weed they call it. These are the things which can come up to that level. Another one is the submerged, which is especially they use the hydrilla plant and other things are the submerged. It won't come above the water surface, but it will be below the water surface only, but it will be absorbing the nutrient and other things. It will be enhancing the dissolved oxygen content also. When the combination, so these are the variants of the constructed wetland. You can also see in the topmost corner how, see, the emergent, free floating and submerged plants are grown in the constructed wetland, and it is shown for just understanding purpose. So next one is based on the types of the flow, whether water flow is free water surface or subsurface horizontal flow or vertical flow. So you can see here the constructed wetlands are further classified based on whether it is a free water surface flow. Free water surface flow in the sense the water will be flowing in the top. So it will be totally exposed to the surface. Whereas in case of subsurface horizontal flow, water flow or the sewage flow will not be seen. It will be flowing below the subsurface only. No one will notice that there will be a sewage which is flowing in the bed. The 10 to 15 centimeter free cover is given in order to avoid the exposure of the sewage and or the odor nuisance or fly nuisance and other things. And the next variant in this one is the vertical flow. Vertical flow in the sense the water will be, the sewage will be sprinkled from the top. It is like a sand filter. It will be percolating down through the root zone media, and while coming out, it will be treated. It's getting treated naturally. So these are the variants of the constructed wetland. It is based on the types of the macrophytes grown and type of the flow, horizontal flow, vertical flow, and free surface flow. These are the variants of the constructed wetland. Now, just for example, I'm showing you the free flow, these are called surface flow, free floating wetland. So what are the weeds you can see is the wetland plant we can call, that is the lettuce. It is having the only 10 centimeter roots. It is floating from the top and it will be absorbing the nutrients and it will be absorbing the organic matter. It will grow in their size and number. Thereby it is it is further polishing the treated water. So this is the one which is available in where we are having this kind of treatment plant in our B.E.L itself. So next one is, this is the floating wetland. Many places you can see in many lakes are there coming with the floating wetland. The entire bed will be made as a floating. So this can be why they call it as a floating wetland. There will be a floating bed, and this vegetation will be grown. This bed can be pulled to the surface area, thereby the weeds and other things or the reeds and our wetland plants can be cut and it can be harvested and it can be put back. So this is also one of the kind which is having the high practical application. So this is also having the high practical application. This is the constructed wetland. It is constructed in one of the place where you can see it is like a garden or it is some field. But this is a treatment plant. First one you can see is the horizontal subsurface flow. Constructed wetland, and the treated water is let into this collection tank where there are also some floating plants are there that can be treated as a surface wetland. So these are the application, and this is how the constructed wetlands are picking up and coming up in the industry, in the wastewater treatment application. Now, what are the mechanism which is happening in the constructed wetland? In any treatment plant you would have studied, there will be a primary treatment, secondary treatment, and tertiary treatment. The process involved in these wastewater treatment are physical process, chemical process, biological process. All processes are taking place in constructed wetland also. But what is happening in the constructed wetland is all these processes are taking concurrently in a reactor. In the same reactor, concurrently all these processes are taking place. Let us go through one by one. What are the physical processes which is taking place? You all have studied. There will be a filtration system. There will be a sedimentation system. There will be like with respect to filtration, you would have studied for coarse screen, fine screen, like that. Similarly, here also, what happens here is vegetation in the surface flow wetland. The roots act as a filtering media in the surface flow wetland. Whereas in case of the subsurface flow wetland, the material, substrate material which is present in the wetland act as a filtration media. Not only this act as a filtration media, this gives the hold fast for the microorganism to grow. That is the advantages of this. Next one is the chemical process. See, chemical process basically happening is the oxidation reduction of the organic matter, which generally takes place in any of the treatment plant. Similarly, same process happens in constructed wetland also. Oxidation of the matter will be there, reduction of the matter will be there. In addition, based on the substrate media what we use, there will be a precipitation and removal of certain element also is possible. Some places they use iron cinders for removal of the certain chemicals. And when phosphorus is high in the effluent, they use the iron cinders as a filter media, thereby the phosphorus can be removed. So these chemical processes are also taking place. Precipitation of the heavy metal also can take place based on the type of the wetland media we use, and oxidation reduction are the common process due to the supply of the oxygen by the plants, and as well as the reduction and other things taking place due to the microorganism which is present inside the root zone media, and destruction of bacteria, destruction of pathogen also takes place in this process. Next come to the biological process occurring in the wetland. See, biological process, the photosynthesis is the one which will diffuse us oxygen from surface to the deep zone. That is called the root zone. And plants also will absorb the organic matter in addition to the removal of, in addition to the uptake of the matter by the bacteria and other things. The process, some of the process, the fermentation process takes place, nitrification takes place, denitrification takes place, and phosphorus removal takes place. All these are happening inside the root zone media, which I have shown in the first page. First one of the slide I have shown where the plants are grown, there will be a media. In this one, that is called as a reactor. In this reactor, all these processes are taking place simultaneously and concurrently. Now, this is just for the pictorial diagram to show. See, there will be a sedimentation will be there, thereby the BOD will be removed up to 30 to 40%, and solids also will be removed. Then it goes to the anaerobic zone will be there. Then there will be aerobic zone, and further, based on the type of the disinfection, either natural disinfection or sometimes we need to add the external disinfectant. Based on that, the highest quality of the water we can achieve. You can imagine here how the treated water quality varies at different zone of constructed wetland. It is possible to achieve the BOD below 20 ppm in the constructed wetland. Now let's get into the design aspects of this. What are the design aspects to be considered while designing a constructed wetland? So first and foremost, the site selection play a very, very important role in design of constructed wetland. We have to see which is the location and what is the temperature of that, because see, sewage is being treated. If it is a cold climate, the water is getting freezed. So in that case, what is the types of the plant, area required, all those things has to be designed, and we have to see whether constructed wetland will work out or not for such places. So site selection play a very, very important role in design of the constructed wetland to address the temperature, photosynthesis rate, and rainfall. So next parameter which is to be considered is substrate selection in constructed wetland. Substrate selection is having the two roles here. One is the maintaining the hydraulic permeability of the root zone, which is very, very essential. Otherwise, the constructed wetland gets choked up. In order to have a flow and have the hydraulic conductivity, the root zone size will be selected. Selection of the root zone size is very, very important. Not only that, it gives the surface for the microbial attachment. See, there should be some hole first, otherwise whatever the microbes go, it will be washed away. So this is providing the two things. One is the selection helps in maintaining the hydraulic permeability. Second thing, the surface area. If you provide bigger particle, the hydraulic conductivity will be good, but surface area will be less. On contrary, if the smaller size of the media is selected, surface area will be high, treated water quality will be very good, but hydraulic conductivity gets affected. The flow will start overflowing from the top surface. So it will come to the top and it will spill over in between the constructed wetland. That happens. Choking of constructed wetland is considered as one of the failure mode of the constructed wetland. So we have to ensure that once the constructed wetland is designed, it should be operational for minimum 25 years. So that considering that aspect in mind, and the media size and other things are designed. Next one is the plant selection. Plant selection also play a very, very important role. Whatever the plant selected, that should be tolerant to the water logging, anaxic and hypereutrophication. Otherwise, if it is not tolerant, the plant will die. Maybe it cannot survive in the hypereutrophication because of the higher ammonia formation inside the root zone, or water logging. Also certain plants will die. So considering this logging condition, anaxic condition, hypereutrophication condition, the wetland plants are selected. These are called the water tolerant plant. There are several water tolerant plants are available. Based on that, the plant has to be selected. If aesthetic appearance has to be given, there are certain plants are like canna can be planted, and if the only the removal is considered, then there are other plants are there. Vetiver and other things can be planted and it can be selected. See, plant selection is also based on certain absorption rates also. Certain plants is very tolerant for the heavy metal. Those plants also can be taken up, which I will show you what are the plants have been considered for the constructed wetland in the later slide. Then sizing. Generally, approximately they tell that 5 meters square per person equivalent is considered for the constructed wetland. This is the approximation, and moreover, there is a scientific calculation methodology is also available. Next one is the aspect ratio. Aspect ratio play a very important role. What is the length width? See, length width ratio play a very important role in order to avoid the overflow and to maintain the hydraulic conductivity. Uniform distribution of the flow is also very important. That also happens based on the aspect ratio, length width ratio. Next one is the hydraulic loading rate and hydraulic retention time. See, hydraulic loading rate also determines the what area should be considered, and hydraulic retention time. Higher the hydraulic retention time, the higher removal of the organic matter, which is as usual in other constructed wastewater treatment plant also. Next one is the pollutant loading rate. Pollutant loading rate determines what is the outflow characteristic. So there are certain calculations are also given. Up to 130 to 200 kg per meter square per year is the hydraulic loading rate to be considered for designing the constructed wetland. So next one is the hydraulic conductivity. As I mentioned, hydraulic conductivity is a very important parameter. Otherwise, the long term operation is not possible. Moreover, uniform operation also has to happen. Whatever the sewage fed in the inlet should uniformly distribute across the root zone. Root zone is called, it is a combination of the media and the plant roots. That is called the root zone. It has to distribute uniformly so that it has to come in contact with the roots as well as the media where the bacteria are grown on the surface of the media. So, there is a limiting capacity also. We cannot load anything excess also because the outflow will be totally disturbed. So, as per the EPA guidelines, it says 80 to 120 kg per hectare per day is said to be constructed if we have to achieve BOD less than 30 ppm. This is the EPA guidelines which they have arrived. It's been tried at 230 kg per hectare also. What is happening is the BOD of the treated water is in the range of 40-50, but removal rate found high, but the outlet quality parameter is also exceeding the required limit. So this is the formula which is used for the constructed wetland. See, all equation based on e to the power kt first order kinetics only. There are different formulas were available. One is generally used formula, one is the Kikwich formula, is there another Kedlock one. These are the things which is widely used. One is all these things derived based on the e to the power kt formula only. See, surface area is derived based on this. What is the inflow characteristic of the sewage? What is the outflow characteristics? See, based on the inflow BOD and outflow BOD, surface area is arrived. So surface area is arrived based using this formula. See, advantage, see what is the differentiation between these two formula? See, Kedlock and Knight formula, which is having it is considered some background concentration. If the consider the constructed wetland as a reactor, it is having the continuous flow. The inflow in the range of 200 will be continuously entering, and at the discharge point, the treated water having achieved the BOD of the 30 ppm will be there. So there will be a continuous inflow of the BOD. There will be a background BOD also. Another things, due to dying of the bacteria and the roots of the plant, that also will be adding to the BOD increase. So these are the options considered in the Kedlock and Knight formula for arriving the surface area. So these are the what are the parameter considered in the design equations. So these are the empirical equation based on the long-term study they have arrived. So if the what should be the minimum area required to remove this one, in that case, what are the background BOD to be considered? So in one of the experiment we conducted and we arrived, which formula is giving more realistic result or near to the one experimental result. Here we found that KC model, where it is having the background concentration considered and all, which is that result is coming very near to the experimental result. Hence, in one of the study, it is concluded, the study is done by me only in our plant. See, we feel that the KC model is giving the nearest result compared to the Kikuch model. So this is being studied in one of my PhD paper, which was required for the academic purpose. So as I told, what are the plants and how the configuration have been made? Different people have made different kinds of constructed wetland. See, constructed wetland, initially they will be making a free floating, then a horizontal flow, then vertical flow. Constructed wetlands are being constructed. The advantages and disadvantages of each type has been compensated, and such combinations of constructed wetlands are being used. We can see the vertical flow will be there, horizontal flow will be there, and they are using the mixture of phragmatic Australia will be there. So these are the plant which is given in each column. What is the sizes also being varied, and the hydraulic retention time they have varied, and the tested parameters also being varied. So accordingly, there are several research papers were available wherein they have used and they have proved the constructed wetland application. So in Indian condition, we are widely using the whatever Designation ODS can be used, and if you use the another plant which is widely used, Canna indica, which is giving the flower, it is having the good aesthetic appearance, it will be given. So, and cattle also widely is being used. Cattle you can see in many of the lakes, you can see the cattles. So this is how one, for my study purpose, how it has been constructed and how it has been implemented and how data have been collected. So this is the constructed wetland, and you can see the inlet point, how it is being constructed to ensure that the sewage is getting uniformly distributed. The next one is the media, and next one is the planted one. Actually, how the setup will grow. So here you have to notice that these plants are grown in the jelly medium only. We have used the 20 mm size gravels. In that only plant have been grown. See, 5% of the soil has been used just to cover the roots, to initially to protect the roots. Otherwise, it may die. Later on, it will grow by itself. So this is how, what is the fed water and how the treated water is collecting for the further analysis and further assessment. So once it comes to the mature stage, constructed wetland looks like this. So what is the flowering one is the Canna indica, which gives pleasant appearance. What the another plant you can see is the vetiver zizonidias. So this is giving the higher removal efficiency, that is giving the good aesthetics. Based on our application, we have to decide which plant has to be used. So like other things, process control parameter also can be monitored in this one. So generally it is not being monitored. They design as per the size and the surface loading and other things we told. But nowadays the technology is also coming to have the online monitoring. Here what we monitored in our case study is how the what are the kinds of reaction which is taking place inside the root zone media. See, root zone media will be generally constructed up to 0.5 meter to the 1 meter they will be constructing, and we wanted to study the how much deep roots will go what are the different types of action taking place, whether it will be totally aerobic process or it is anaerobic process or anaxic process. So what exactly is happening, that is being studied in this monitoring of the constructed wetland. The intent here is, generally if the oxygen is available, that is the preferred electron acceptor by the organisms. Once the oxygen deficit happens, then the nitrate will come over. They will prefer nitrate as electron acceptor. Then will come as a sulfate as an electron acceptor. So that is how it goes. If it is a aerobic reaction, oxygen is the electron acceptor. If it is an anaxic, nitrate is the electron acceptor. And if it is a methanization process, biomethanization process, then sulfate is the electron acceptor. How to identify which process is happening at what level? For this, we have devised certain monitoring mechanism that is based on the oxidation reduction potential, which we will be studying through the in further slide. So what we consider, there will be a micro-environmental condition created within the root zone itself, which is having the temperature variation and which is having the dissolved oxygen content, pH variation, and oxidation reduction potential. Generally, people, what they do, they take the sample, measure the DO, and they will conclude that yes, this is the BOD level. Once the DO goes below 0, then we directly considered it as a anaerobic. But in between, there is a anaxic process also that can be very clearly brought out if the measurement system is done with respect to ORP, which we will show you in the further slide, how we can arrive whether it is in a aerobic or anaxic or anaerobic. So this microenvironmental condition we have studied by selecting these parameters. So these are the meters. The pH meter is there, conductivity meter is there, ORP meter is there. So these are the things which is directly, it is an on-site measurement. Generally, it will be taken and measured at the laboratory. These are the electronic instrument available for on-site measurement. So this we have plotted the profile. What is the interaction among all these parameter and all. So along the length and along the width, how the changes are happening. So which is measured in terms of the ORP value. See, ORP value at the top and bottom and along the length, how it is varying. You can see here. Say there is a huge variation is there, the ORP along the length as well as along the depth. This point we will not discuss in detail, which takes a lot of time. What are the interaction with respect to each depth, length, HRT. You can see in the first profile, ORP profile and its interaction, how the ORP is having the interaction on the hydraulic retention time, organic loading rate, length and width. So what point I'm trying to make you here is, see, each stage can be measured, whether it is a aerobic process is taking place, anaerobic process taking place, or anaxic process based on the oxidation reduction potential. If the ORP value, oxidation reduction potential value, is in the range of 300 to 700, it is considered as aerobic respiration is taking place. Otherwise, if it is coming below 100 to 350, it is considered as nitrate reduction is taking place. See, whatever the oxygen molecule available in nitrate, NO3, that will be used by the denitrifying bacteria as a electron acceptor. So thereby nitrate is getting converted into the nitrogen gas. If not, then manganese will come into picture as electron acceptor, iron, sulfate. So this is how, based on the ORP value, we can come to know which process is predominantly is taking place. Again, see, if the anaerobic process, sulfate come as a major role as electron acceptor, thereby the biomethanization is taking place. Like that, we can conclude based on this oxidation potential reduction values. So this is pH also is varying. We know that anaerobic process pH will vary between 4 to 6. So like that, it can be concluded. So temperature variation also we studied, because higher the temperature, the rate of reaction is also higher, in order to find out what is the temperature variation within the root zone media. So then effect of plant development inside the constructed wetland is also very, very important thing. See, there are 2-3 contradictory results are there in the scientific community. One portion is the root zone. The root zone is getting choked due to the continuous growth of the roots and accumulation of the root zone media and accumulation of the organic media. Other reports are saying that the root zone will expand the media, thereby the hydraulic conductivity will be increased. But in our case, what we studied for the 6 months, we found that gradually there is a decrease in the hydraulic conductivity over a period of time. So this is how we study with the control without planting in one of the constructed wetland, what is the hydraulic conductivity, and with the plant, what is the hydraulic conductivity have been studied, and it's been reported in our one of the case study application. So you can see the root growth. If the canna plant is used, how much will be the root, and if the vetiver is used, how much is the root penetration inside. These all the things are studied in case. You can observe here, canna, it is having the thicker primary roots but lesser secondary root, and depth of penetration is also lesser compared to vetiver. So when compared with the canna and vetiver, in the result it came out that vetiver is having the higher removal efficiency. You can see after 10 months we removed and checked what happened inside the constructed wetland, how the media getting clogged inside the root zone, and how it is got clogged in with the roots. All those have been studied. So just another 10 minutes left out. I will in 5 minutes I will be just taking you through the few case studies of constructed wetland. So 1.5 MLD STP is available in Heroldli, Bangalore. So this is how they are constructing. This is a vertical flow system they have established. Whatever you have seen in the other slides are the primary screening facility for the primary treatment in order to avoid the choking of the bed, and thereby after the screening they will be pumping it to the constructed wetland. It is available in here only, Bangalore only. So another classic study is the Jakkur, where these are the plants available in the Jakkur constructed wetland. So you can see the treated water quality. What they do here in the Jakkur is they have got a treatment plant. From the treatment plant, they discharge water to the constructed wetland. From the constructed wetland, it comes to the lake bed. So this is one plant we are rejuvenating in our Bangalore. It is the Bomsandra Lake, where B.E.L is taking construction of the 10 MLD STP for rejuvenation of this lake. We can see most of the time lakes were dry. Now the treated water is being used to augment the evaporation and transpiration losses, and thereby they are making the lake full all the time. So this is the rejuvenation of that Bomsandra Lake what we have taken. So it is having 754 million liters holding capacity if it is treated. And these are what are the benefits which has been planned by this one has been proposed here. So this is the sequential batch reactor which is constructed in this plant, just for your information. So bottom one are the grids, and you can see as a very big boom which is in silver color is the decanter, wherein this comes down during the decanting phase and remove the water and comes to the top. Thereby having the secondary clarifier has been avoided in this sequential batch reactor portion. What the process happening is fill and aeration will be there. That will be for every cycle is designed for 3 hours. 1.5 hours will be a fill and aeration, another half an hour for the settling, another half an hour for the decanting. That is how the system is being worked. So what are the mechanical screen? The second one show the manual screen and mechanical screen. And this is the SBR basin, and between the two grids of the blue color you can see that is the selector zone, where there will be anaxic process, there will be nutrient, other things will be removed, and another one is the collection sump, because these are the deep collection sump. It is around 8-meter diameter, which is below the ground, because the BWSSB sewer is going at 4 meters from there, what is being taken and it is treated. These are the some systems. Now after that, see now the lake is having 1.5 meter water depth, but as I told, there are a lot of vegetation is there, thereby you cannot appreciate the water. But see, this entire 125-acre lake has been rejuvenated. So these are the small scale application of the constructed wetland they used in the community just for treat the 10 or 15 houses effluent generated in many places. So this is about the constructed wetland, and what I try to communicate over a period of 1 hour is, see now the constructed wetland is going to come up and it is having the wider application and the variants of that and what are the design parameter considered and how the monitoring system is being practiced, and few case studies I have covered in 1 hour. Any doubt or anything if you want to ask or you can share, it is open to you. Rajesh sir, I have completed my presentation. Over to you, sir.
Thank you, sir. Thank you for the excellent presentation. Students, if you got any queries or any questions, you may kindly raise it now. Okay. Also, I wish to inform all the students that when sir was making his presentation, basically understand that there was application of knowledge that has been gained. So one takeaway from this session is, when you plan your final year projects or when you plan your mini projects, you can always think of doing a project which is an attempt to resolve a problem which exists in the society. So when you speak about wastewater treatment, okay, constructed wetlands are very beneficial. So why not? Why not you people also think of undertaking project works, and probably if you have, observed very carefully, you can actually, start off these kind of researches in your laboratory itself at a small scale, and then you can, enhance the size of the units. So what is important for us is it is not just merely the knowledge that you gain, but also apply the knowledge so that you can be solution providers for the society. And please remember when sir spoke about constructed wetlands, invariably, he was speaking about advanced tertiary treatment, wherein he was again depending upon the biological systems, okay, which is more or less biomimicry. So for every problem in the society, there is a solution the nature is offering us. We need to observe it very carefully. So thank you, sir. It was an excellent presentation. Now, I would request the students, if you got any questions, you may kindly raise it. If you got any questions, you may kindly raise it. Any doubts? Any queries?
So what is the efficiency of this wetland?
No, efficiency, one thing you can consider, it can be able to achieve below 20 ppm. See, efficiency again, what is the inlet versus outlet and divided by the inlet. Okay, so that is the efficiency. Efficiency is achieved up to 90%. Again, it is subjected to the organic loading which we feed. You are getting my point now. If you feed 300 BOD, we will be able to bring it down up to 60 ppm. If it is 150 is applied, we will be able to achieve 10 ppm. Again, efficiency is the one thing which is only a mathematical calculation, inlet versus outlet divided by inlet. Here, organic loading plays an important role. Are you getting my point?
Yes, sir.
Am I clear?
Yes, sir. Thank you, sir.
So what sir was saying is it all depends on your design. Okay, you do a particular design, and based on the design, as he said, it can attain about 90% efficiency. So it's all control setup. At the same time, it also depends on your influent characteristics and your desired level of treatment. Is it correct, sir?
Yes, that's what I'm trying to
Yes, sir.
make.
Yes, sir. Any other questions, friends? Any other queries? Anybody else has any other questions? Okay. If not, then I would like to take this opportunity to extend the word of thanks. Sir, Shashibushana sir, extremely glad and pleased that you could make time for us. We were struggling for quite a few time because of your commitments. I understand that defense minister is also here. So thank you, sir, for making time available for us and sharing your valuable knowledge with our students. And I'm sure that this session will be encouraging quite a few bunch of these kids to undertake their research probably in this domain itself, wherein they can be providing solutions to the society. So on this occasion, I'd like to thank the management, the principal, my colleagues, and my dear students, for being part of this. And also, last but not the least, uh, warm greeting and a warm thanksgiving to Dr. Shashibushana, Manager Environment, Bharat Electronics Limited, for uh, providing his valuable knowledge on the significance and design aspects of constructed wetlands. What has added value to this presentation is the knowledge that he has shared with respect to case studies. Students do kindly make a visit to the Dodbomsandra Lake, which has been taken up by B.E.L as a part of the CSER. So these are the ways forward, steps forward for us to conserve our nature. As we step into 2021, I hope that this will be more fruitful and eco-friendly, and of course safe and healthy for one and all. Thank you, sir. I thank you for your kind presence. Thank you, dear
Thank you very
students.
much, sir.